All right, we'll pick up from Section 1, Lesson 1 in Unit 2, looking at dynamics. In the example we went through here in class, we're looking at how to calculate the force of gravity. So, example 1, a spring scale can measure up to 500 newtons. What's the maximum mass that the scale will support? So first we have the force of gravity is equal to mass times gravitational constant. And the gravitational constant is always negative or 9.8 meters per second squared. So in this case, we were given the force of gravity that's acting upon an object as 500 newtons equals mass times 9.8. So to find the mass, we solve for m, divide both sides by 9.8, and the mass of the object would have to be 51 kilograms. Question 2a, what's the weight of a 2,500 kilogram truck on Earth? Well, it's 2,500 kilograms. We multiply that by 9.8, and we get 24,500 newtons. Now remember, force is measured in newtons, and newton is the force it takes to measure a 1 kilogram object at 1 meter per second squared. Now we'll write that scientific notation. So decimal will be behind the first digit, and we have two significant digits, our lowest number in our answer. So 2.5 times 10 to the 4, because we had to move the decimal 4 places forward. And B, what would be the weight of the same truck on the moon, where the acceleration due to gravity is approximately 1/6 that of Earth's? Well, in that case, it's going to be 1/6 of the answer, which is 4.2 times 10 to the 3 newtons, or 4,200 newtons. Okay, example 3. On planet X, a rock is 150 kilograms and has a weight of 525 newtons. You need to find the acceleration due to gravity on this planet. So what's the gravitational constant on this planet? So I'm going to pause the video and give you a moment to solve the question. Okay, now you had a moment to go through it. We know the force of gravity on this planet is causing the rock to have a weight of 525 newtons. Mass of the rock is 150 kilograms. And we need to find the gravitational constant. We don't know. And our formula is mass times gravity. So we know 525 newtons, 150 kilograms times gravity. So to find gravity, we're multiplying here, divide both sides by 150 kilograms. And the gravitational constant will work out to 3.5 meters per second squared. Now if you're paying attention to the units here, you have newtons over kilogram. A newton per kilogram is equal to meters per second squared. And B, what would be the mass and weight of the same rock on Earth? And we'll give you a moment to solve that. Okay, next. So mass, remember, is a constant. Mass doesn't change. It's a amount of stuff that actually makes up an object. It's weight that changes. So since mass is a constant, mass of that rock is 150 kilograms. But what weight will that rock have on Earth? So apply our formula. And on Earth, again, the mass stays the same, 150 kilograms times 9.8 meters per second squared. And what will be 1,470 newtons, or 1500 newtons. Since we have two significant digits there, we have 2 there. Remember, only leading numbers are important. Alright, that's it for this section.